Hey guys, how's it going? Here's our review video for our test tomorrow over quadrilaterals and scale factors. So the first thing you're going to need to do is to take a look at this picture here. So here are all of our different quadrilaterals. What you need to be able to do for your test is be able to classify the different types of quadrilaterals, so I would make sure that you know this list very well. So our first question here asks us to classify this quadrilateral, so I'm going to refer back over here. So we have a trapezoid, parallelogram, and kite. This shape right here, we would call this one a parallelogram because it is a quadrilateral and where sides are parallel and congruent. We know that they are congruent because we have these four little tick marks here. So here we would call this a parallel. And then what we're going to do is go back here and see if we can go any farther with it. So this is a parallelogram with four congruent sides. Here's a parallelogram with four congruent sides and four right angles. And then we have a rectangle. So actually, we can go even farther than a parallelogram. So we're going to call this one a rhombus. So let me go ahead and erase parallelogram. We're going to call this one a rhombus. Alright, now let's look over here. So we're classifying this shape. If we classify this shape, we are going to have a kite. And now we need to classify the quadrilateral, then find the value of x. So we can't say that any of these sides are the same because we don't have any of these tick marks, right? So we can't say that it's a rhombus. So we're just going to have to look at it. We'll say that this one is a parallelogram. And then we need to look for the value of x. So remember, the inside measures of a parallelogram are equal to 360. So we have 135 plus 135. Plus 45 plus x equals 360. 270 plus 45 plus x equals 360. And then we have 315 plus x equals 360. So x would be equal to 45 degrees. Now let's look over here. Here we have an example, and we're going to refer back to our shapes. So in between a trapezoid, a parallelogram, and a kite is a quadrilateral, two pairs of congruent adjacent sides. So we will have to look at our shape again. Here we can't say that these two sides are congruent because we don't have our tick marks. So because of that, we're going to say that it's just a parallelogram. We're not going to say it's a parallelogram. Let's look back here. We cannot be a trapezoid because we don't have one pair of parallel sides. It can't be a parallelogram because all the sides are not congruent, and it cannot be a kite because we know nothing about the sides. So this one is just a, sorry about that, this one is just a quadrilateral. You add up all the sides, you have 90 degrees plus 90 degrees plus 35 degrees plus x. You know it's equal to 360. So you have 180, 215 plus x equals 360. So we have 360 minus 215. So a measure of x would be 145 degrees. Make sure you put the degree sign. Alright, now let's start talking about scale. So this one says find the missing dimension, use a scale factor of 1 to 20. So we have our scale factor, which we said is 1 to 20. And we're trying to figure out x over 90. Okay. Now a couple different ways you can do this. You can either multiply straight across, or also, the cross product property will always work. So we're going to do 1 times 90 and 20 times x. So we have 90 equals 20x. We divide by 20 on this side, divide by 20 on that side. Let me plug it in my calculator. You would get x is equal to 4.5 inches. Here we're finding the next missing dimension. So we have a scale factor again of 1 to 20. Alright, so this is how I set up my proportion. I could do cross product again. So 1 times x would give me x. And then 20 times 3.75. Remember, on your test you will be able to use a calculator. So here we have 20 times 3.75, which gives us an answer of 75 feet. Our next one says the scale drawing is 1 centimeter to 65 meters. The length of a drawing is 5 centimeters. What is the actual length of the object? So we have, oops, sorry about that. I'll move that back. 1 centimeter to 65 meters. The length of the drawing is 5 centimeters. What is the actual length of the object? So here we can do our cross product again. We can say x is equal to 65 times 5, which we know that 65 times 5 is going to give us 325. So our actual is 325 meters. Then our last one says the scale drawing of a soccer field shows the field to be 6 inches long. The actual field is 300 feet long. So remember that our formula for finding the scale of a drawing is model over actual. So you have 6 inches over 300 feet. And we need to find a scale of the drawing. So if you look back here, this is our scale. So our scale is always going to have these labels on the end of it. But then if you look back here, our scale factor is not. So actually, I'm first going to start by finding the scale of the drawing. Okay? So we know that we have 6 inches to 300 feet. If we go ahead and simplify that down, and you take 6 and 300, you're going to end up with 1 inch over 50 feet. So this is going to be my scale of the drawing. Now to find my scale factor, I need to make sure that I don't have these labels. So I need to get them both to be the same label. So I'm going to keep my 1 inch on top, but I need to turn this 50 feet into 1 inch. So I'm going to show the conversion over here. I have 50 feet over 1, then 1 foot is 12 inches. So then if I multiply across, 50 times 12 is going to give me 600 inches. So I would need to change this to 1 inch over 600 inches, which would reduce down, or actually, sorry, would not reduce down at all, but I would have a scale factor of 1 to 600. So that's how we find the scale factor. Okay? Now on your test tomorrow, make sure that you show all of your work, and I'll see you guys tomorrow. Good luck.